Hello again, Year 10. This week we are going to be carrying on looking at the topic of surds, and in today's lesson we are going to be looking at how we rationalise a denominator. However, before we get started, let's do a little activity to wake up our brains. I would like you to use Pythagoras' theorem to find length x. But unlike Year 9, I don't want you to write your answer as a decimal. I would like you to write your answer as a surd in its simplest form. So I would pause the video here because I'm about to go through the solution. So first of all, this is a short side problem. The 9 is the hypotenuse, the 9 is C. I can label x and 6 as my A and B. So Pythagoras' theorem says a squared plus b squared equals c squared. So 6 squared plus x squared equals 9 squared. Working this out, 6 squared is 36 plus x squared equals 81. So x squared is 81. Take away 36. And you might have jumped in straight at x squared equals 9 squared, take away 6 squared if you preferred. And that is 45. So x is the square root of 45. However, that isn't a surd in its simplest form because the square root of 45 is the square root of 9 times the square root of 5. So the best answer is 3 root 5 centimetres. So I hope you've been able to print out a sheet for today, but if that's not been possible, please just put the title Surds 5 in your book. Remember to put the date down for today and the objective, be able to rationalise the denominator of a surd. Now that word denominator is something we should be familiar with. We have numerators and denominators in fractions. The word rationalise means making a number a whole one. Remember, a surd can also be called an irrational number. So if we have a fraction that involves surds and there is a square root in the denominator position, this is not considered to be in its simplest form. So what we're going to be trying to do today, perhaps one of the hardest skills with surds, is looking at how we can rewrite an expression such that the denominator is not a surd, but the expression is still equivalent. And the way that we're going to do this is we're going to think carefully about what we can multiply the numerator and the denominator by. As long as we multiply a numerator and denominator by the same value, the fraction remains equivalent. So let's take a look at our first example, which is 1 divided by the square root of 2. So we have the square root of 2 as our denominator. So that is not in its simplest form. Well, what can we multiply that by to make it a whole number? We can't multiply it by a whole number because that would just be something like 3 root 2 or 7 root 2. However, if we multiply it by another square root of 2, then we will end up with the square root of 2 times the square root of 2. And the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is a whole number, 2. So we are just timesing root 2 by itself, and that will rationalise the denominator. So if I times the top by root 2, the numerator is now root 2. If I multiply the denominator by root 2, we've just worked that out, that is 2. So written in its simplest form, 1 over root 2 is rewritten as the square root of 2 over 2, the denominator now being a whole number. Let's look at our next example. 6 over root 3. What do you think we need to multiply this one by? We multiply by the square root of 3. Because the square root of 3 times the square root of 3 is just 3. The numerator is 6 times the square root of 3. So that is 6 root 3. But this one simplifies a little bit more now, because we have the 6 lots of the square root of 3 divided by 3. And 6 divided by 3 is 2. So this ends up being 2 lots of root 3. Let's look at a third example. We have 4 divided by 2 root 5. What do you think we need to multiply this one by? Now, I think there'll be 1 or 2 of you that think we need to multiply by 2 root 5, but actually we don't need to. We can just multiply by root 5. Let's see what happens. If I multiply the denominator by root 5, obviously I need to multiply the numerator also by root 5. Well, 2 times root 5 times root 5. Well, root 5 times root 5 is 5 times 2 would be 10. So that makes my denominator 10. And my numerator is now 4 lots of root 5. This can be simplified a little bit, thinking of this as a fraction 4/10, because I can divide the top and the bottom by a common factor of 2. So this one becomes 2 root 5 over 5. In my final example, I have 2 terms on the top for my numerator. But how can I rationalise the denominator? Yes, I'm still multiplying by root 2. Root 2 times root 2 is root 4, or 2. Now it is like I'm multiplying all of this numerator by root 2. So I've got 2 times root 2, which is 2 root 2. And root 6 times root 2, which is root 12. Now, we've had root 12 come up quite a lot because that simplifies. Root 12, remember, is root 4 times root 3, which is 2 root 3. So this is 2 lots of root 2 plus 2 lots of root 3, all divided by 2. But since everything divides by 2, I can just write this final answer as root 2 plus root 3, which was considerably tidier than my starting point. Now you've got a couple of options here. You could pause the video here to access these questions, or you could, if you prefer, go back to my instructions and find the link to the PDF version of my PowerPoint. There are questions number 1, like my first 3 examples, and question number 2 is like my final example. If anyone wants to try something a little bit harder today, I have put an extension question for you to be thinking about. More on how to do these next lesson. Remember to spend 5 minutes checking your answers at the end, marking with a different coloured pen. And as always, if you have any problems, remember to contact me in the Ask the Teacher channel.